data sets that live throughout the organization outside of health. You are welcome to chime in at any point. You can add questions in the chat. I'll try and keep my eyes on chat, or just pipe in by unmuting yourself and rattling off whatever question you have. Let me go ahead and share the deck. And with me is also Jit Bhattacharya. He is Senior Solutions Architect for Expertech, which is one of our third-party vendors that we work with exclusively on AWS and GCP around HIPAA compliance. Their specialty in security and cloud has been kind of instrumental in kind of designing our path and working with our security team here. I know we kind of covered this a little bit last time. PHI, what is PHI? The 18 identifiable data elements. The one that I like to point out to everybody is just kind of that 18th one, any unique identifying number, characteristic, or code. So anytime we get in a discussion around genomics, it's a pretty easily decided case that it's a unique identifying code or characteristic, but that's usually up for debate with the genomics folks. They sometimes think that they don't fall into the HIPAA identifiable elements, but I like to remind them that that's the ultimate fingerprint. But there's lots of research on that. If you're interested, I can forward you plenty of content that will help validate that argument. Okay, so one of the things that we started with was just identifying the framework that we were going to have to comply with to meet HIPAA standards. If you're familiar with HIPAA, HIPAA really doesn't specify technical standards, but it says you need to protect it. So what we decided to do was approach it from the compliance framework standard of NIST 853, which meets FISMA moderate standards. So also, CIS baseline level 1 requirements. And then one of the things that we did was kind of map out what currently our organization does for security in terms of the NIST and CIS standards, and then figure out how we're going to tailor it to these new set of services, guidelines, and use cases. And with each use case, we have an overall system security plan that we developed that is hundreds of lovely bedtime reading pages of documenting the technical and the organizational controls. And really the technical controls for me are the easier part. It's documenting the organization controls, around how you, are doing user provisioning, how you're onboarding things. Those sorts of pieces are definitely the more challenging portion of building out that system security plan. So the other thing that I like to discuss with groups when you're getting into the cloud is, making sure you have that BAA in place. It basically extends the concept of the covered entity to the partner or the member organizations that you're working with. I'm sure a lot of you are familiar with it. If you aren't, again, plenty of bedtime reading. If you just search Business Associates Agreement, your organizations probably have one. It's a lot of legalese about extending that concept of the covered entity. So AWS offers HIPAA eligible services, and a lot of our research customers assume that, okay, it's HIPAA eligible, so I must just be able to use it kind of as is, and that's not really the case at all. You still are having to build in a lot of those controls around those HIPAA eligible services to make sure that you're actually HIPAA compliant. So those of you who are familiar with this one, there's the concept of, AWS is responsible for hypervisor and below, and we're responsible for kind of everything in this top, the kind of teal or seafoam green, whatever color that is, all of these pieces. And that really depends on the service. Some of the managed services kind of have a little bit of a hybrid responsibility model for us versus them, but this is the general concept, and that was the approach that we took in dealing with each of these use cases that I'll kind of walk through. And as you know, there's a bazillion different, I think 180 some odd services now that are released. There are a lot that are specifically for security, governance and management, and identity and compliance. So it's kind of figuring out how you're going to be using these services, and then putting the Lego pieces together to kind of architect secure solutions. And then with our security team here in information services, each time we iterate or we make changes or we add an additional service, we're adding on security design documents or system design documents that kind of document the use case and how those use cases map back to the controls. So I see there's some chats coming in, but I don't know if that's related to, is this being recorded? I don't know if is this being recorded?
Yes, we're recording this.
Okay. So in California, we need to notify everybody in advance, but that's fine with me. I don't mind being recorded. But anything that I do or say doesn't represent my organization. Just kidding. Anyways, so the concept or the approach that we took was figuring out, you know, the different mechanisms we're going to need to cover within AWS, how we're going to identify, protect, detect, kind of automate some of those responses and be able to investigate things and then recover from any sort of failure event or, God forbid, a breach or some other sort of corruption. So there are services that cover all of these. This is definitely not a comprehensive list, but this was kind of our current state baseline for things that we're using in our environment to kind of approach each one of these different topics. And we'll walk through each of those as we walk through kind of the layers of security that we've embedded into the platform. Okay, now it's not moving forward. There we go. So I mentioned before Expertech. We brought them on board. We initially started with AWS ProServe back in 2016, 2017. You know, AWS will help you kind of get off the ground, but they're not meant to be long-term operational support partners. So they gave us, you know, 4 or 5 different companies that we could look at to evaluate kind of long-term support for both junior and senior level support in different areas. We are not, in terms of information services, a strong Linux or open source support group. So it was critical that we brought on somebody or a group that not only could help provide some of that support, but also was familiar with security process and documentation. And that's where Expertech kind of came in. And Expertech also offered us what's called a blended rate. So whether it was senior or junior level support, it was kind of a single blended rate that we could kind of work with, budget out. As you know, it's not always easy to be able to kind of forecast a budget when you're dealing with different rates. And so that was kind of a critical piece for us. So in terms of the overall system security plan, we went through and we mapped out each one of the controls as they map back to NIST 853. At the time, now mind you, this was almost 3 years ago when we started this. The reason we picked NIST 853 was that there was a HIPAA crosswalk. There is now one developed also for NIST 800 171, but we haven't transitioned back to this. 853 covers a much wider array of controls. So some of them are relevant, some of them aren't. It just depends on kind of the pieces that we were responsible for. And some of these map back to, you know, they're for example, AWS controls like, you know, physical security in the data center. That is something that, you know, as part of the BAA and Amazon's responsibility, they take ownership of, and they produce security artifacts that you can actually get access to. If you're the owner of your account, you can get access to all of those artifacts, you know, the ISO 27001 or 27001, any of the SOC reports and things like that. So that is where we kind of started from, and this was definitely the most painful process as we rolled forward, because it's just an absolute ton of documentation. So an example of one of the design docs that we put in place. So for each use case that we go through, and this one's a fairly simple one. This is AWS transfer for SFTP. which leverages S3 on the back end. But we were actually really surprised at how many people. We thought we'd just be able to give researchers access to S3, and they would, that would satiate some of their need to be able to get data into the environment. But SFTP still bears its teeth, and so this was kind of the documentation around how we're building out the secure architecture, leveraging that service. And then what's not shown here is some of the individual mappings to the technical controls that roll back to that overall system security plan. So the other thing that we're leveraging, and highly suggest if you're not, organizationally, it was really important that we have everything be able to roll back up to a consolidated bill, but then be able to distribute bills to the individual accounts, and then also have other levels of control that you can affect the entire kind of ecosystem for. So as you build out orgs, which is their consolidated billing, it also has this concept of these kind of sub-OUs, just like in Active Directory. So we have, even though this is the health org, and actually here we're calling, when Campus kicked this off in terms of creating the consolidated billing, they called it the HIPAA org. That's not actually true. We're calling it the health org, where we do have HIPAA data, but there's also a lot of non-HIPAA services that are going on in the environment, and we segregate by these sub-OUs what types of data we allow in the environment and what we don't. And we have definitely a bunch of different operational controls on the HIPAA side that we're not enforcing on the non-HIPAA side. But the neat thing with this from a billing standpoint is that it all rolls back up into one purchase order for the entire organization. And then there's a finance team that actually distributes out by account and by tagging strategy the bills to who's using what. So I like to refer to, our approach to security is the layers of onion, and we're going to walk through each one of these. And there's a couple of additions that we threw in, like logging isn't covered on the baseline security onion, but we'll cover that as well. So we're going to start off talking about some of these use cases of using security groups, VPC, Firewall, and encryption in transit and at rest. Even though I know at rest isn't another, as a baseline for everything that happens in the HIPAA environment, we are literally encrypting everything traffic-wise and encrypting everything at rest. And that can prove challenging to prove with some of the AMIs as you build them out, but that is one of the things we work with security on to kind of vet out so that they are comfortable with having this HIPAA environment in the cloud.
There's a question in the chat about authentication being used for SFTP. It says, do you create IAM accounts for all your users, or are you able to use Active Directory or other central systems?
We're actually using a key-based approach. There are multiple options for using that SFTP, but we're using keys that allow users or applications into the environment. And I'll get into that a little bit as we kind of, I'll talk through some of the use cases, and I'll actually pass the baton over to Jit as we talk about the SFTP, but it's a key-based approach. There are users in that service that we add in, and then they have their private key on their side, and we have their public key. That sort of, anyways, okay. We'll move forward, but I promise we'll get back to it. Okay, so everything that we're doing in the HIPAA environment, everything that was in that kind of red box in the consolidated billing org, we are running through Palo Alto virtual firewalls that also connect back to the physical firewalls here at UCSD. The infrastructure is all using UCSD CIDR block space so that we can connect back to local resources if we need to. And there are some cases where we're kind of leaving everything out on its own island and it doesn't necessarily need to connect back to the organization, but the hub, if you will, for all activity between VPCs and accounts is all through the Palo Alto firewalls, and that establishes those IPSec tunnels for each of the connectivity pieces, which performs a lot of the encryption. And this is a typical networking diagram of a giant spider web of connections that our network services here helped to connect and constantly updates and manages. We're using Palo Altos and Panorama to kind of push a lot of those controls that we do on-prem up to those virtual firewalls and vice versa, so that the mapping goes bidirectional. The other thing that I wanted to point out up here, and I know this is kind of hard to read, this top box is our management account where a lot of our core services live. The other thing that we're doing here is consolidated all of our logs, CloudTrail, VPC flow logs, as well as system logs, all come back into this single bucket that we use for kind of our consolidated logging. And I'll talk a little bit about what we're doing with those logs and how we're kind of managing event findings and event discovery with Prisma Cloud, which is now another Palo Alto product. Originally, we were using Evident.io, and Evident was purchased by Palo Alto, and then they also bought Redlock, so they moved us from Evident to Redlock, and then now we're in Prisma Cloud, which is the next iteration of a long kind of evolution of monitoring our API traffic as well as logs. So Palo Alto, I mean, you all know what firewalls do. It is basically allowing us to kind of block traffic, looking for malicious profiles, etc. We also have Wildfire, which does some kind of cool crowdsourcing of new potential threats. So if something is coming through the firewall and it's not sure exactly what that packet has in it, or if it's potentially malicious, it actually shoots it off to this Wildfire kind of sandbox, if you will, where it goes and opens up the packet and sees what's in there, and then it can crowdsource this potential new threat to all Palo Altos across the Palo Alto network. Again, I'm not a Palo Alto salesman, but that actually has been a very unique feature in the, for us in the cloud that allows us to kind of get real-time threat notifications on things that are happening out in the wild that we may not be aware of. Okay, so in terms of bastion hosts and how we're approaching that, along with we're going to roll back to some of the things like the security groups and how we're covering them. I'm going to pass the baton over to Jit to cover this next session, this next session or section.
All right.
Jit?
Thanks, Andrew. So this diagram goes into a little more, lower level and detail about the boundary controls that Andrew was specifying. And if we start off from the right bottom corner, you can see the virtual Palo Altos sit inside, the VPC, which is called our management VPC. And then there's the on-prem Palo Alto, which is sitting, which is our boundary firewall at UC San Diego Health. Okay, so the connectivity from on-prem network to any access within our VPC environment goes through that, Palo Alto to Palo Alto connection, right? So, and the VM, the Palo Alto VM, not only acts as a firewall, but that is also our methodology of using the transit VPC gateway. Now, when we set this up about 3 years ago, AWS had still not come up with their transit gateway service that was released after we put this in place. But this was the way to do transit VPCs at that time, and we still continue doing that.
So we are looking to try to transition over to the managed transit gateway, but that's going to be a long process.
So any connectivity from like VPC to VPC, has to go through this Palo Alto, which acts as the hub. This is a hub spoke model. But any traffic inside of a VPC is not controlled by the Palo Alto, right? That is not controlled by the firewall. That would be controlled by the security groups. So as you can see, like if you go into the management account on the left-hand side, that's where all our Bastion hosts sit. So any privileged access to like the resources within the AWS has to go through the Bastion host. It just adds another level of security. It's a layered security model and reduces the surface attack area, right? So if somebody were to go in like as an admin, they would go in through this network, from the Palo Alto, hit the Bastion host, and from the Bastion again go to the Palo Alto and then go to their account and their specific resources inside of their VPC. Okay, so that is the methodology for any kind of privileged access. The other access would be end users. If, for example, there is a need to open up an application to the internet, right? In that case, that access would happen from the right top, which shows the internet. From there, it would go through, an elastic load balancer. That's another thing we put in place, right? Another layer of abstraction out there. So there's no direct access to the resources. And we can put a WAF in front of it if required. But that goes through the elastic load balancer and then again hits the Palo Alto virtual machine. And from there gets access only to the public subnet zone within their VPC. So each VPC always has 3 zones, the database, the app server, and then the public web tier zone. So any public access or application access can only hit that public zone or the third layer. So that's how we use the Palo Altos and the boundary controls. And this one actually gives another view of the same thing, what we mentioned. So the top layer shows any kind of privileged access. So it would go, a user would hit the Bastion and then can access the different resources. And you can see that with the red line going all those ways. And then if for application users, they would hit the elastic load balancer, hit the Palo Alto, and then have access only to the application server, and which sits in its own subnet and is also controlled with their own security group. Right? And this shows isolation between different research groups. So it's an extension of the previous slide, but what it shows is we have different Bastion hosts for different research groups, right? And each of those bastions sit on their own subnet, again, for isolation. Now, if we start with the top Bastion host, that is for, the UCSD Health IS team. Now, because they are managing, they're in charge of overall management for patching or maintenance, they have access to all the different research groups on the left-hand side. So if you follow the red line, they have access to all the different accounts and all the different VPCs, right? But now if you take on the second one, that's one specific researcher, and they can only follow that blue line and will have access to only data that they have, right? They cannot cross, reach onto another researcher's any kind of resources or data, right? It's just creating isolation using subnets and accounts using this methodology. Okay. We also create similar, stratification and classification inside of a VPC. So it's based on least privilege, and depending on what the user needs, we have user policies. Like, there could be an end user policy, a developer policy, an administrator policy that gives rights, to the instances and what data they can access. It's highly controlled using pretty low level, AWS policies that we use. So there was a question, do you have need to run both Linux and Windows bastions? Yes, we do. Um, so it's really based on, what they have the requirements are and, what they like using. We are also, and Andrew, if you want to touch on this one, we are also looking at using AWS workspaces as Bastion. Today we use EC2 instances, both Linux and Windows, but we have been looking into both AppStream and workspaces, and we will transition to those in the future. Workspaces.
From a cost standpoint, both AppStream and workspaces just make a lot more sense. Well, AppStream makes the most sense financially. We get an interesting mix of reactions in terms of using a Bastion host from our research community, because a lot of times what they want to do is install a lot of their computational packages on the Bastion host itself rather than spinning up compute inside the environment. So that's just kind of an education process that we go through as we work with the researchers to say, no, your Bastion is literally just for connectivity. No, you can't store files there. No, you can't have your R Shiny app running on your Bastion host. The thing that AppStream allows you to do is just give a very small subset of tools that then easily allow them to click through and get access to their resources, rather than having kind of this stateful infrastructure constantly running, which is how we're approaching it now. But like Jid had mentioned, we're looking at AppStream as well as workspaces. We'll talk a little bit about workspaces for what we're providing researchers for a kind of another use case, and kind of how that is evolving. We're creating virtual research desktops for our Clinical and Translational Research Institute that pulls out a lot of big PHI workloads directly from our EHR, or not directly from our EHR, but from our clinical data warehouse that consists of Clarity data from our EHR. But we'll cover that use case in a little bit.
The one other thing we wanted to cover on this right-hand side is that we heavily use tags for doing a lot of the classifications and controls. Who can start, stop instances, who can create instances, that sort of thing. And we do enforce mandatory tagging for some things using Lambda functions. And then we also use config to ensure that nobody's wrongly changing tags and enforcing the correct tags out there. Go to the next slide. And this comes back to that original diagram. Now it gives you a better overall picture of what we're doing. So on the top, again, is the management account, and that is where the Palo Altos sit, and also our Bastion management or any managed services that are common to all accounts sit. Like we will also have like a managed AD service out there. It also captures, like Andrew had mentioned, all our centralized logging. So every log from every account that's under the HIPAA org, whether it's VPC flow logs, CloudTrail, or system logs for any instance or database, is captured out there. And then we do have, again, we'll cover it later on, but we do have AMIs that have got the agents installed and configured. So anytime anybody spins up an instance, it will automatically spin up the agent and will write to that specific centralized bucket.
So there's a question asking about inspecting encrypted traffic in real time.
So, so we have, again, this goes back to security, and again, Andrew, I'll let you speak to it, but at this point, we have not been inspecting traffic real time in that sense, although, we capture every log, so we can, drill down to any specifics either within the VPC flow logs or the Palo Alto logs. It will be captured. So if it's, egress, ingress, or, any traffic in between VPCs, then it will be captured in the Palo Alto, and anything inside of a VPC would be captured in our VPC flow logs, right? And so we have built some, reporting tools around that, but we're not doing any, traffic inspection internally at this point. And,
Not
Andrew,
currently, but we are evaluating it right now. But the performance hit on those virtual servers. So when we started this, those are VM 100s. I mean, they are like the smallest Palo Altos, or actually they're the biggest Palo Altos we could afford at the time we were launching this this whole process. So we're looking at kind of scaling that up because we are in a multi-cloud environment here, meaning we have a lot of enterprise resources that are in Azure currently, and we're building out a GCP HIPAA environment, kind of actively right now, along with Expertech. So we're evaluating kind of the performance hit, and then you know, they're basically experimenting with decrypting that traffic in real time, but currently we're not doing that. But we found when we flipped that switch, it kind of ground things down to a very slow crawl for when we had that turned on. So networking team is kind of evaluating and then figuring out, you know, how we need to scale up to kind of meet that that need. Though a lot of the sources in the groups that we're working with already have other things going on in the environment where the files themselves that we're moving up there are kind of already in a trusted state. Yeah, that's something that we're looking at as a future state for sure.
And Andrew, there's another question, you know, it's asking about managed endpoint detection and response services. And so we do use, so Palo Alto acts as an IDS IPS and also does a lot of the, you know, virus checking and stuff like that. And any kind of egress ingress in our environment has to go to the Palo Alto. So that's definitely, you know, one of the things that's out there. But we also use both Sophos and Sentinel-1. We are moving to Sentinel-1. And like I said, we have custom AMIs, and we'll cover it later on. So those things are part of any, you know, instances that are launched, right? It'll automatically be installed in there.
And we'll talk a little bit about some of the native AWS services that we're leveraging also for endpoint management / config / monitoring. We're using guard duty, we're using inspector, we're using config for addressing different issues within the environment. I don't know how detailed, we won't get too deep down that rabbit hole, but we will certainly cover it at least at the, I don't know, 10,000 foot level. I hope that sort of answers it. So in terms of, speaking? Oh, sorry, my chat just caught up, so I just saw that question. I'm gonna go through some of the AMI hardening, patching, the IAM roles for EC2, logging, logical access controls, user authentication, etc., as well as the encryption at rest, which is kind of part of our AMI hardening process. So we are leveraging a bunch of different tools in AWS. You know, we already mentioned CloudTrail, VPC flow logs. We are leveraging config and Trusted Advisor for monitoring resources, and then also efficient use of resources. It does give you some feedback in terms of, you know, under and overutilized resources within the environment. Though we are using some third-party tools, and one of the tools that we just recently started to leverage is something called Beam from Nutanix for cost monitoring and kind of cost forecasting. They also have a compliance module that goes along with it, but that functionally was less mature than what we're using with Prisma. So we're sticking with Prisma for now, but evaluating Beam because the campus actually purchased Beam with a 3-year license. So at no cost to us, we're getting to leverage it, which is a fairly nice deal for us. And then again, I mentioned guard duty before for enabling kind of host detection and host vulnerability and compromises. We turned that on and were pleasantly surprised. And I think I still have a slide in here about that. Let me go through it. So For account access and controls, as well as encryption, at the account root level, we're using MFA tokens in partnership with our security team. We had an event here at UCSD a number of years ago where a researcher with a very valuable data set proverbially backed the truck up on a Saturday and moved to another organization and took all their data with them. Part of that was that the university didn't actually have root ownership over that account. So putting in the Alto MFA tokens in partnership with security allows them to kind of have the, in partnership with myself and Jit and the rest of the cloud team, control over root ownership and root access. Meaning if I need to go in as root, I need to go get that MFA token, I need to sign it out from security. So kind of the same thing with like the nukes, the two keys to turn to launch anything. Can users build, sorry, we just got another question. Let me roll through the slide and then I'll get back to the question. So we are enforcing MFA. We are leveraging IAM right now. We are transitioning over to using AWS SSO along with our Active Directory. That is, we built out most of the roles to be able to transition over, but currently we're leveraging IAM exclusively along with Duo for user access. That becomes kind of a management nightmare, though we are using roles and groups and things like that to kind of be able to place people in the appropriate groups, but we'll be transitioning that over to leveraging AD, because then our user access team here in information services could receive the ticket and be able to place them in the right AD group, rather than having the user access team having to leverage or not relearn, but learn AWS and how they would do it in there. We require all users to be on the UCSD Health VPN, which allows us to kind of validate that at least a user is using AD credentials along with the Health Duo for MFA. And then that also gives us kind of a limited access radius, meaning there's a pool of IPs assigned to VPN users for the cloud or that have cloud access. So we're kind of whitelisting that specific segment of addresses for access into the bastion. Like I said, we're evaluating the ADFS, but I think, we had leveraged ADFS and started to build out ADFS for integrated health access using AD, but we are probably going to roll towards the AWS SSO because it actually is fairly robust and a heck of a lot easier for us to manage. But we'll update you at some later point once we get that rolled out. Very limited use of access keys for S3 directly. That is, and we have a constant key rotation. We actually are a little more aggressive than the recommendation. I think we're going with 30-day key rotations for S3 access. But like I said, there's a very limited use of that. Primarily, we're leveraging other mechanisms to kind of control access into S3 specifically. And we have S3 lockdown, so there's no no ability for users to make those buckets public. That we do have in some of the non-HIPAA areas public buckets that are used for other projects or other use cases. So we leverage a lot of IAM roles for EC2 for access into S3, which is another mechanism. So you're not attributing it to the user, but you're giving it to the compute itself. Because the compute is locked down in terms of who gets access to it, that also kind of limits the kind of, I don't know, not really blast radius, but the ability for users to get onto the EC2 and then go places they're not allowed to. We just basically provide a role to that EC2 instance. At rest, in terms of encryption, we require all volumes to be encrypted. We have some Lambda functionality that basically if somebody spins up an EBS or EFS volume that isn't encrypted, it automatically will shut that down. And then in terms of the in-transit, we covered the IPSec tunneling SSL and other policies that are kind of brokering that encryption for in-flight. And then, can users build apps to be used in compute? This is a question that came in on the chat. So we actually usually assist the groups with building out the application stack that is on the EC2 instances to a certain extent. It's an interesting use case where it's kind of outside of what information services is supposed to be delivering to our end customers. But what we've done is created partnerships with a lot of those member departments and research groups with Expertech so that they can do some of that high-end application or configuration that if they have the resources to be able to do it, that's one thing. But if they don't, they have to basically create a purchase order with Expertech to kind of allow them to develop that out in a secure fashion. Most of that application development, though, is something that we kind of are working with our security team as well, because we aren't a software development shop by kind of nature. A lot of, this is a medical center that is used to kind of shrink wrapped applications that have already been developed. And then, they just kind of work with the vendor. In the case of development, we're working with them on what that process is and how that process works in terms of secure application development. So guard duty, I kind of mentioned this before. We flipped this switch on when guard duty was first released. We thought that we were doing something wrong because there was no findings in any of our environments. It is pretty nifty. You can have kind of one pane of glass in a central account that all findings roll back up into. There's no reason that we could see not to turn this on. I mean, our bill for the first month was 51 cents. That was a pretty low cost threshold, and I think they refer to that as budget dust in most organizations. But at 51 cents is impactful. Consider it based on resources too. If you have hundreds or thousands of resources out there, guard duty could get a little more expensive. But when we flipped it on, we literally had no findings. I called AWS, our solutions architect, and we rolled some sample findings into the environment just to make sure it was working, and indeed it was. We have had some findings come in through guard duty, and guard duty also rolls back up into your logs, depending on your API and monitoring tools. A lot of them can ingest that guard duty information as well, which is nice because we're actually sending that back through Prisma event findings. They also ingest the guard duty findings, and then that also is reported back to our Splunk instance that goes back to our security team. Trusted Advisor, I kind of mentioned it before for cost. It gives you some fairly low-hanging fruit in terms of fixing things within your environment. Like you can see the unassociated elastic IP addresses, which cost you $5 a month if you're not careful. Underutilized EBS volumes. Sometimes that's meaningful, sometimes it's not. It just depends on the researcher, because they are kind of very spiky in their use of the compute environment. So sometimes it may seem like it's an underutilized EBS volume, but currently they have that resource turned off. But when they need to go and process something, they'll go back, turn the instance on, but you're still paying that EBS volume cost. Trusted Advisor also has some performance suggestions. It also does fault tolerance. We're not doing, with a lot of the research workloads, we're not doing a lot of HA or fault tolerant kind of designs. This is just, here's your compute, do what you need to do and get it done. Again, it's just another kind of tool in your tool bag to address issues within your environment. And then it also does security checks, though we have a plethora of other opportunities or systems that are reporting back a lot of these security findings. So Inspector, we run regular assessments on our environment. You can kind of see last run. This is obviously from a while ago. It gives you, it reports back on findings within that environment and those resources. So it also gives you pretty robust reports or detailed reports on when things were run, how often they're run, and what the findings were within that environment. Let me just flip through because I know we're getting shorter on time. So this is an example, of the last run assessment. It gives you the target, tells you when it was run. So that also gives you the ability, when an auditor comes in, to kind of roll through and produce auditable reports on resources within your environment. And that agent is installed on our AMIs by default. Okay, so let me just go to this. The AMI hardening, this is changed a little bit because now encryption across accounts is not an issue, meaning that encryption keys that are created in one account can be shared across accounts. So this was our original process where we'd pull something out of the market, we'd do all the CIS level hardening, including making sure that all the right security mappings were in place for or removed for individual AMIs that we created, and then we'd share that across those department accounts. Now we can kind of keep it in that central management account and share it across all of the accounts, which is kind of taken out this whole left square where once we have the encrypted instance or encrypted AMI, we can share that across accounts now without having to transfer it over, because what we were having to do before when you couldn't share the key is share an unencrypted AMI and then encrypt it in that account, which just created this whole other work chain, which now we're fortunate Amazon listened and allowed for kind of that cross-account sharing. In terms of the AMIs that we offer out to users and ones that we built out so far, this isn't comprehensive, but this is just some of our biggest use cases: Amazon Linux, Windows 2016, and I guess we're really far in the future. That's supposed to be 2019, but 2019, I guess we'll be able to use that that future server instance. But Red Hat, we have a machine learning AMI along with the genomics pipeline, this BioBC AMI, RStudio, Jupyter Notebooks. And then as well, and then as well with RDS, we've hardened out and built out, they're not really AMIs, but essentially secured Microsoft SQL, MySQL, Postgres, Oracle, and Aurora. Though we're primarily using MySQL, Microsoft SQL, and Postgres. We do have a couple use cases where Oracle was going to be in play until they found out how the licensing was going to cost them, or what the licensing was going to cost them. And Aurora as well. And Aurora, from a performance standpoint, we're only using in one use case, but it is pretty robust and frankly frighteningly fast. So I mentioned Prisma. Prisma is one of the tools that we use that sits over all of the APIs within AWS. So it ingests the CloudTrail, VPC flow logs, guard duty findings, and a number of other findings within AWS, but those are some of the biggest ones. It's kind of a unified dashboard that covers all resources within the environment. You have to give it read or read-write access, because you can actively go in there and remediate issues as you find them. We are not using the remediation feature currently. We're just triggering alerts. So this is just an example of the different policies within the environment. You can create your own custom policies. You see the little add button up above. So if you wanted to find things that are outside, or maybe you don't agree with the severity that is currently mapped, you can create your own custom policies within there. Well, that's an example of creating your own custom policy. And then we're feeding all of the Prisma findings back to HTTP log collector or event collector from Splunk. So all of those findings that are generated in Prisma Cloud, instead of sending all logs back to Splunk, even though I know Splunk would like that, we're just sending the findings and events that are triggered in Prisma back to Splunk. So that was an agreement we came to with our security team and our financial team. because sending all your logs back to Splunk is super expensive because there is just a ton of white noise that those logs collect. Now, you can get into the finer points of what is white noise, but like I said, we can create custom policies and dictate what we want to in terms of severity define those as, and still forward those back to Splunk if there's something that's not being triggered that security wants to be alerted to. And then for S3 access, so this on the right-hand side shows the policies that we associate with buckets. We have specific policies that are developed based on the individual research group's needs. So, read-only developer policies and then administrator policies, where, developer policies, they can create and write, but they can't delete content. User policy is, they can read, they can kind of list and get files, but not put files in there. And then we also put lifecycle policies, depending on the group again, lifecycle policies to transition things to Glacier, and now some of the other Glacier offerings within AWS to reduce cost based on kind of the usage profile of data itself. So hopefully we haven't put you to sleep, but we'll go through some of the use cases that we have actively in flight right now, which is much more of the fun stuff rather than the security pieces. So Jit, you want to hit this one? So this
yeah, I think we're
go for it.
Getting close to the time, so I'll very quickly go through this. So this was the system we put in place for accessing the SFTP or AWS services. The one thing it does not provide is the ability to scan files as they're loaded. So that's the requirement that we wanted to put in place. So if anybody's trying to upload, we do want to do a virus scan on that before it's actually usable. So what happens is once they put something, it goes into what's called a quarantine bucket. And with the use of SQS and a Lambda function, what we do is we pull that file into an EC2 instance, run a scan, and if it passes the scan, then that file is moved into an approved folder on the right side, the green one. Or if it doesn't, then it goes into a failed folder, and the person gets notified. And all the results are stored in an Amazon DynamoDB and also tagged on that particular file.
And one of the big things that we had to do was transfer a lot of stuff that was on-prem into the cloud. So down here you can see a picture. There's Jit with somebody who doesn't work at UCSD anymore, who shall not be named. Just kidding, is Peter Wong, moving stuff from all this local infrastructure onto Snowball and then transferring it up to AWS. So this is one of our newest use cases where we are actively doing sepsis prediction machine learning. Basically, we're taking data out of the hospital systems. So there's these monitoring systems, the Philips systems, as well as stuff coming directly out of Epic, the ADT interface, which the interface basically is about basically moving patients in and out of the hospital. It kind of sends it sends HL7 messages to CorePoint, which is our integration, our university integration engine. We're actually forwarding messages about patients in the ICU to our own interface, our research interface down here that's in the CTRI account, as well as the monitoring that's coming out of these Philips units. So these Philips monitors are things like respiration, temperature, O2 levels, and that's super meaningful for sepsis prediction. And the faster you can see trends happening, the better off you are. And the issue that we have if we were taking all of that information out of Epic is Epic treats it as a legal record. So meaning that data may come into Epic, but they won't ship it out via CorePoint for maybe 15 minutes until a nurse certifies that, yes, I've gone back and checked the patient's temperature, their respiration, their O2 levels, etc. We needed that in much higher resolutions. So we're pulling directly out of these PICs classic and PixIX servers directly into the SmartLink server, and a frequency of every 3 seconds, which is daunting in and of itself, but it provides a much more accurate sepsis prediction model. So the idea is that you know, the data flows from these 2 centralized servers into this deep ice platform, and the deep ice platform makes predictions on kind of the relative likelihood that a patient will be developing sepsis based on, you know, their temperature going up and their respiration is increasing. And like I said, you know, it sounds a little bit dramatic, but every second really does count, meaning, you know, within 3 minutes, you can see a trend of a patient turning septic, and the quicker you can treat them and then provide the information back to a physician about what, you know, what triggered this prediction is super meaningful in an ICU environment, or frankly, in any environment. Okay. Jit, you want to cover the genomics? I know we've got, I think we are at time.
Yep, we are at the top of the hour.
So I can provide these slides. I'm not sure the best way to get them to you, but we'll figure that out.
Yep, yeah, if you'll get them to me, either a link to them, then I can add that to the document, or if you want a copy, then I can put them out in the folder where we put the document.
Absolutely.
I'll just kind of throw out, are there any last minute questions we have for either presenter? From anybody?
And you're welcome to contact us directly if you have other questions, comments, concerns. We put everybody to sleep. We're mission accomplished.
Oh, this was an excellent presentation.
Thanks.
With that, there are no additional questions. Once we get the slides out and to get the recording uploaded to YouTube, we'll send a note out to everybody letting them know the slides and the YouTube video is there. But otherwise, we appreciate everybody's attendance, and we especially appreciate the presentation.
Absolutely. Thanks very much for the opportunity.
Thank you.